In question 2 of this exercise, we have to find the three sums given below. So we have these three arithmetic progressions, and in each case we are given the first three terms and the last term of the arithmetic progression, and we have to find the sum of terms. So we don't have the number of terms, but what we do have is the first term and the last term, and of course we can find the common difference in each case. So there are two formulas that help us find the sum of terms of an arithmetic progression. So here are those two formulas. So the first one is Sn equal to n by 2 into 2a plus n minus 1 times d. This helps. This formula can be used if we have the number of terms, the first term and the common difference. And the other formula is Sn is equal to n by 2 times a plus l, where n is again the number of terms, a is the first term and l is the last term. So in this case, what we will do is, because we don't have the number of terms, we will first find the number of terms for each case, and then we will use this second formula to find the sum of terms. Okay, so let's start with the first part. So in the first part, the sum that we have to find is 7 plus 10.5 plus 14 all the way up to 84. So first we'll find the number of terms n. So to do that, we will use this relation for the nth term of an AP, Tn equal to a plus n minus 1 times d. So in this case, 84 is the last term and we have to find its position, because that will give us the number of terms in the progression. So 84 is the last term, 7 is the first term, and the common difference is the difference between any pair of consecutive terms. So that's 3.5 in this case. So we are going to write 84, which is the nth term, is equal to a, the first term, plus n minus 1 times d, and d is 3.5 or 3.5. Okay, so now 84 minus 7 is 77. So 77 is equal to 3.5 times n minus 1. And from here we get n minus 1 is equal to 77 by 3.5. 77 by 3.5 is 22. So this means that n is equal to 23. So there are 23 terms in this progression of terms. And now that we have the number of terms, we can apply this formula for Sn equal to n by 2 times a plus l. So S23, or the sum of these 23 terms, is equal to 23 by 2 into a plus l. So what is a? So a is the first term, 7, and what is l? L is the last term, which is 84. So 23 by 2 into 7 plus 84, or 23 by 2 into 91. Now 23 by 91 is 2093. So 2093 by 2, this is equal to 1046.5. So this is our answer for the first part. The first sum is 1046.5. Now let's do part 2. So in part 2, the progression or the sum is 34 plus 32 plus 30, and this goes up to the term 10. So once again, we'll first find the number of terms in this progression, and we will make use of this relation Tn is equal to a plus n minus 1 times d, where Tn is this last term, 10. So we will write 10 is equal to a. What is a? A is the first term, 34, plus n minus 1 times d. Now what is d? So you take any pair of consecutive terms like 32 and 30, and you see that d is equal to minus 2. 30 minus 32, so that's minus 2. So from here we get 10 minus 34, or minus 24, is equal to minus 2 times n minus 1, and this gives us minus 24 by minus 2, that's 12. So 12 is equal to n minus 1, and from here we get n is equal to 13. So there are 13 terms in this progression, in this sum, and now we can apply this formula Sn equal to n by 2 times a plus l to find the sum of these 13 terms. So we will get S13. The sum of these 13 terms will be 13 by 2 into a plus l. So what is a? A is 34 and l is 10. So 34 plus 10. And now we get 13 by 2 into 34 plus 10 is 44. And then we get 13 into, so we get, if we divide by 2, we get 22. So 13 times 22, and 13 times 22 is 286. So the sum in part 2 is equal to 286. So that completes part 2. Now let's do part 3. So in part 3, the sum is, the progression is -5 plus -8 plus -11, and this goes up to -230. So this is the sum that we have to find. Once again, we will first find the number of terms using this relation Tn equal to a plus n minus 1 times d, where Tn is this last term -230 and a is this first term -5, and d is the difference between any pair of, d is the common difference which can be found by taking the difference of any pair of consecutive terms. So that's, for example, if I take -8 and -11, we see that d is equal to -3. So let's plug in these values. So we get -230, which is Tn, is equal to a, which is -5, plus n minus 1 into d, which is -3. Okay, so now we get -230, and this -5, if we bring here, becomes +5. So we get -225 is equal to n minus 1 into -3. So we get n minus 1 is equal to -225 by -3, and this is equal to 75. So n minus 1 is equal to 75, and this means that n is equal to 76. So there are 76 terms in this progression, and now we can apply this formula Sn equal to n by 2 into a plus l to find the sum of these 76 terms. So that sum will be S76. It will be equal to 76 by 2 into a plus l. So a is -5 and l is -230. So -230 is the last term, and we get 76 by 2, that's 38, into -5 plus -230 is -235. And now we take this product, 38 into -235. This will be equal to -8,930. So the sum in part 3 is -8,930. And with this, all 3 parts of question 2 are done. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.